Today we're going to talk a little bit more about convergence and divergence of a series, specifically geometric and what we call nth term. Now we talked yesterday about what a sequence is. A sequence is just a list of numbers, 1, 2, 3, 4, 5. A series is the sum of those numbers. For example, we would take the sum of the previous term. So my series would start off with the first term, which is 1, and then I add the next term to it, which gives me 3. And if I add 3 to that, I get 6. If I add 4 to that, I get 10. And if I add 5 more to that, I get 15. So a series is more of a sum. As a matter of fact, what you're going to see from like pre-cal, when we're given a series, we use summation. So let's say we're given a geometric series here, 3 over 2 to the n, and we want to find the sum of that series from n equals 1 to infinity. Well, I know this is geometric because I can write this as a sub n, and this is 3. Factor out the 3, and I'm left with 1 over 2 to the n. So that's our geometric formula. So the series is very simple. It's, if I write it out, the first term, if I let n be 1, I get 1/2. Let n be 2, I get 3/4, 3/8, 3/16, and so on and so forth. So this is a series, and we add them all together. We're going to take a minute, and we're going to go ahead and find the first 10 sums of the sequence of partial sums. Now we call this a partial sum because there's an infinite number of terms in our series. We want to find only the first 10, so we call it a partial sum. Now we're going to do this on the TI-80, on the TI Nspire, and I'll show you how to do it in a second. But to show you basically what we're doing, we're going to find the sum. So we use the letter S. The first sum is just 3/2. To get the second sum, we're going to take that 3/2, we're going to add the second term to it, 3/4. Now this is easy, that's just 1.5. This is 2.25. To find the third term in our series, we're going to take that 2.25 and add 3/8 to it. And that's going to give us, I did this already for you, 2.625. Now after this, it gets a little bit chaotic, right? So remember, I'm just adding. I'm taking my previous one. I'm taking my previous sum, and I'm adding the next term. It gets a little chaotic. So to help us out with this, we're going to use our calculator here. So to do this on your calculator, this is what you type in. First, turn it on. Make sure your memory's cleared. Doc. Enter. So I'm going to type in cumulative summation. So cumulative summation of a sequence. So just like we did the other day, so I'm typing a sequence. So type in SEQ, and I just literally just type it in. And it says to write out what my function is. In this case right here, write as a fraction. I'm going to go 3 over 2 to the x, comma x, my first term, to my last term, comma 1, comma 10. And I hit enter. Now notice it gives me everything as a fraction. Okay, so I'm going to change this to a decimal. Menu, number, convert to a decimal, hit enter, hit enter, and I get this. So if you notice, we get the 1.5, the 2.25, the 2.625, and we get the 2.815. That's my fourth term, is this 2.8125. My next term, now you're going to scroll over the 2.90625. My sixth term, it's 2.9. Now I ran out of room there, it doesn't show me, so I might have to use a little bit of an arrow. Oops, I can all the way to the end. One of these days I'm going to figure out why it does that. Let me try something here. Enter. That still gets me to the end, so I'm going to have to scroll back to where I was already at. So I'm looking for the 2.90. 2.97, 2.9. Okay, there we go. 2.9625. So my next one is right here. 2.953125. And my next one, the seventh term, 2.9765625. And then my eighth one, S sub 8. Again, I'm just going to keep scrolling. This is exciting. I know what you're thinking. So I get, what's that? 9.2.98828125. And then my next one, 2.99414. And it's actually 063. And then my last one, if I keep going over to the very end, S sub 10, I get 2.99707033125. And that's the sum of my first 10 terms. The sum of the first two, the sum of the first term, the sum of the first two, the sum of the first three, the sum of the first four, the sum of the first 5. Now, sometimes though we only want to get the last partial sum. To find the last term, we're going to do the same thing. Okay, so if I just want to find the last term, I type in just the sum of the sequence. So enter, escape. You know what? Doc B, delete it all. There we go. So what I'm going to do is I'm going to find the sum of a sequence. SUM of a sequence. Open parenthesis, sequence, SEQ. Open it up again, I just type in my function again. 3 over 2 to the x. Oops, delete, I think I had a decimal there. 2 to the x, comma x, right? Comma 1, comma 10. And I hit enter, and it gives me the last one. Convert that to a decimal. Enter, and I get that 2.99707033125. So that just gives me my last term. We're going to use this one feature more than anything else. Alright, that was the exciting part. So, the question is, what do you notice about the results? Well, if we notice it's getting close, you should notice it's getting closer to 3. So we can say that it is approaching 3. Now, from geometry, you learned to find the sum of an infinite series of a partial set of terms is given by S equals a sub 1 over 1 minus r. So if I write that down here, S equals a sub 1 over 1 minus r, well, my first term in my sequence, my series, is 3 halves. My first term, 3 halves, sorry. R, well, from geometry, from pre-calc, you learn that there's my r value. So we know r is 1/2. Remember, r has to be less than 1 for this to work. So my sum, we get 3 halves over 1 minus 1/2, which becomes 3 halves times 2 over 1, you got to flip it, and we get 3. Very easy to do. So if we type the same thing in our calculator here, again, if you type this in your calculator, what you get for the first 5 terms, the first term becomes 1.5, the second term 3.75, the third term you should get 7.125, the fourth term 12.1875, and the fifth term you get 19.78125. So check that out. Type that in your calculator. I got these from my calculator. Calculator. There we go. My calculator there. Now, what do we notice in this case? Well, it keeps growing without end. So this grows without bounds. So therefore, we can say this diverges. We can say the series diverges. Now, we also know why it diverges. We'll take a look at R. R here is 3 over 2. It's greater than 1. For it to converge from geometry, from pre-calc, you learn that geometric series has to be getting smaller. In this case, I'm multiplying each of the previous values by 1.5. So of course it's going to get bigger and bigger and bigger. So this tells me it diverges, which we're going to talk about in part 2. So practice this. This is just more calculator type of stuff. So if you need to practice it, go ahead. Okay? And I'll see you in part 2.